the idea of removing sodium, using sodium hydroxide to remove ambient CO2 has not been lost. I've been talking primarily about flue stack capture, taking CO2 in two industrial processes side by side and running them together. There was a guy, he's now at the University of Arizona. He started out at Lamont Doherty at Columbia University. His name's Klaus Lackner. And Klaus, I guess he's at Arizona State, not University of. And he has been working on techniques for doing that DAC that I was talking about, direct air capture, using chemistry that's actually sensitive enough to draw CO2 out of the ambient atmosphere, the Earth's atmosphere, right out of the atmosphere. So I could point you to that on the website maybe later and show you some of Klaus Lackner's work. So, but it just goes to show you that once you produce that sodium hydroxide base, at that point it reacts really quickly and reacts spontaneously. So, but the energy investment into doing that process to begin with is to electrolyze the salt water into the base, into the sodium hydroxide. And the Earth would normally do that with photosynthesis. So the energy going in to produce base in the ocean for the critters to uptake carbon is photosynthesis, is solar energy.
Okay. So let me get this right. The process that you're talking about is putting salt water in a vessel and electrocuting it.
Yep.
And exactly. Pulling out chemicals from the seawater and making seashells out of it. Is that roughly
kind
right?
of, roughly, yeah. Yeah, I wouldn't necessarily make a seashell out of it. Actually, I mean, again, I'll maybe point you to the website to show you the exact two equations that are going on chemically. Probably get lost on listeners right now, but you're producing sodium bicarbonate. Sodium bicarbonate is like one of the many salts that dissolves in water. And one of the things that you can do, and that I've been wanting to do, is it's actually beneficial to both groundwater and streams because it's a buffering agent. It reduces pH changes. The pH that will equilibrate in water, if you just let sodium hydroxide build up to whatever concentrate, not sodium hydroxide, I should be careful, sodium bicarbonate, baking soda. If you let water have as much sodium bicarbonate, baking soda that you want, that's going to stay in solution, the pH of that solution without other acids and all that would be 8. So a pH of 8. It has the extra added benefit that when you add acid on one side, it neutralizes the acid into CO2. If you add base to the other side, it'll actually produce carbonate and settle out as carbonate. So it's a buffer. It prevents pH changes. And that's very beneficial in a whole wide range of environmental areas. So ocean water, seawater, it's all benefited by having high bicarbonate levels. So the indirect process of running CO2 through a base like sodium hydroxide is to produce sodium bicarbonate. That can be discharged. That can be discharged right into a riverway, right into groundwater, right into the ocean, and it would have a beneficial effect as long as it's purely sodium bicarbonate. Don't get me wrong. Any kind of industrial product, you have to be careful. There's contaminants with that. But the sodium bicarbonate by itself is harmless. In fact, it's very beneficial. It would clean up acid drainage sites or acid rain problems because it would raise the pH of the water in acid-affected lakes, for instance. So that's now if you were able to put a ton of bicarbonate into your groundwater, into your lakes, and into your rivers, it would ultimately stay in solution and wash into the ocean. And guess what would happen to it? It would be naturally taken up into shells and put on the seafloor. So you don't even have to be sitting right next to the ocean to get this carbon into the water as bicarbonate and send it down to where it's going to be sequestered on the seafloor.
Wow. So completely naturally occurring process. So the problem with my synopsis was that it's actually more like baking soda and less like calcium carbonate, which would be seashells, right?
Right. Yeah, seashells would be the calcium carbonate. Let's put it this way: the sodium bicarbonate, which is baking soda, is very soluble. You can take a teaspoon of baking soda. It's actually it's almost the same solubility as table salt. It's that easy to stir in solution and have it dissolve. The solubility of calcium carbonate is four orders of magnitude less. So we're talking 10,000 times less soluble to try to dissolve calcium carbonate. So once you lock that into a calcium carbonate salt, it's pretty solid. I mean, now calcium carbonate reacted with acid, yeah, you bet. That's going to kick off CO2. I mean, geologists in the group, you put acid on a limestone. We call it the fizzies, the rocks that fizz when you drop acid on them. The saying in geology was, when in doubt, drop acid. So if you didn't know what your rock was, and you had a suspicion that it might be calcium carbonate, you could drop acid on it, and if it fizzed, well, that fizzing is CO2. That's calcium carbonate plus acid going to calcium chloride, basically, and CO2. And so, but otherwise, without the interaction of acid, that is a very stable compound, which is why critters make their shells out, which is why it can stay on the seafloor for a very long period of time and become part of the, the bedrock. Yeah, so.
That's incredible. By the way, everybody should check out John's website. It's canwenow.org. It's very informational. It has a lot of good stuff on there, so definitely go check it out if you want to learn some more about this. In general, John, thank you so much for being thanks for being our next guest on our show. And I just wanted to mention, you should also check out Nevada Conservation League's Facebook page. That's just search Nevada Conservation League on Facebook. And once again, this was the Sustainability Podcast from the Nevada Conservation League. Thanks so much for hanging out with us.
Yeah, very good.